The resulting custom battery is fireproof and waterproof thanks to aluminum composite panels, epoxy resin, and fiberglass. Measurements can be easily taken directly from your photos if you have at least one reference value to supply to the ImageMeter Android app. To stay on the safe side of things, consider making a cardboard template to check whether it fits properly. If you have the same bike as I do, you can use the link in the description to open the SketchUp blueprint of my composite battery shell. You also can find it in the SketchUp warehouse. Aluminum composite panel is usually handled by professionals with dedicated tools like a V-grooving router, which we obviously don't possess, so we are going to cut and groove using an angle grinder with a thick wooden board as a guide. Angle grinder grooving should not go deep for the composite panel to stay intact due to the lack of precision compared to the professional router, and as a consequence our panel is a bit tough to bend. This issue can be remedied by using a gas burner to soften the remaining plastic so that we can bend effortlessly nevertheless. Lithium iron phosphate cells are high current capable, so it is enough to have 3 cells in parallel for each of 15 sequential clusters. A 750 watts electric bike demands at least 20 amps rated BMS to handle consumption spikes. I use the cheapest common port daily 20 amps BMS for 15 sequential phosphate cells, which supply nearly the same voltage as my 13 sequential lithium-ion stock battery. The most accessible way to connect the cells together is to spot weld them with a car battery. That kind of current has to be triggered just for a moment using a switch made from rubber rings and thick copper junk. Balancing wires are to be soldered to the nickel strips using orthophosphoric acid flux with at least 60% tin solder. The most convenient way to test the battery is to put it inside a power tool plastic case and to attach it temporarily to your e-bike. This way it would be easy to troubleshoot any potential issues should they appear. Once the battery is thoroughly tested, it's time to wrap it with at least 2 layers of epoxy resin and fiberglass in order to insulate it properly from the aluminum shell, which usually has some superficial plastic coating. This coating allows carefully packing the battery inside the shell while the epoxy is not yet hardened. Aluminum rivets and silicone compound are the best way to seal the shell tight and sound. Mark the rivet installation points with a permanent marker while wrapping the shell around the battery. Main lithium-ion battery and the secondary lithium iron phosphate battery can be connected in parallel despite urban legends about different chemistries. Just make sure that voltages on both batteries are equal right before you connect them together. Different voltage curves of different chemistries will result in lithium-ion battery handling the bulk of the load at higher voltages, and the phosphate taking over at lower voltages. If you tried mixing battery chemistries, please leave a comment about your personal experience for us to contemplate upon.